All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our corrective measures module. Let's have a look at what we went over today. Now, yesterday, if you recall, we went over the process of making our models more complex, and we were going to increase our neurons to 128. So let's get that going now. We actually did a lot more, so let me get and run this and get things started so I can go over what we went over today. So to make this model even more complex, we can increase the number to 128. To keep things simple for now, we will just use this format and increase our dense layer neurons to 128. Remember, we can do this two ways. So we're just going to stick to this way right here and add our neurons to our 128. You can see we added to our three dense layers, and we kept our output layer the same at a one neuron. So that's compiling. And notice that now we have many more parameters to train on, but we still only have 17 non-trainable. And again, we have the 17 non-trainable parameters because our original model, we had 17 non-trainable and non-trainable parameters. Now that we have increased our dense layer neurons, we have many more parameters to train on, but the 17 remains the same because our normalizer is still the same. Next, we will plot our new model based on the new information we have. And this is the formula for that process. But again, you remember it wasn't working last time and it still isn't working now. So we had to do it manually again. So I went ahead and drew that this morning. So you can see we have our input layer. 8 is our original neurons. Then we have our normalizer for the 8. Then we have our first dense layer. You can see we started out with the 8 original. And then we have our 128 neurons. That's for our first dense layer. Our second dense layer is 128, so it came in with 128 and then left with 128. Our third dense layer, same thing, 128 and 128. And then you can see our output layer, or our last dense layer, came in with 128 and has an output of 1. So notice that this plot represents the new complex model we have. Let me get these little plots out the way so we can finish compiling before I move further. Now you can see that we have our original 8 inputs. Next, we have our 3 dense layers with their 128 neurons. And lastly, we have our output layer with its 1 neuron. From here, we will compile our new model again. We will use this algorithm to run our model. Let me show you which one we ran. And we compiled it like this. The only thing we really changed was the learning rate. We cut our learning rate down from 1 to 0.1. So you can see that here. Notice that we changed our learning rate to 0.1. Now we can run our model.fit on our new data. So let me get and let this compile again. And once this compiles, I can show you. Let me show you the data preparation side of things. This is where we put everything at. So you can see here, here's our model.compile, where our learning rate was cut down to 0.1. And this is how we're going to run our model.fit. And once things compile, I can actually show you the answers or show you the new information that we have to work with. Still takes a while to compile because we added a lot more information. These are our second set of plots here. Okay, and now we should be able to get down to the new things. All right, so let's start up here, or let's just finish compiling and then we'll go over everything all at once. And it should be finishing up pretty soon so we can get ahead and get things going. And we're almost just about more than halfway there. As you can see, we're down to the 70s. We just have to get to 100 and then we should be done. Okay, what do we have to go over first? Let me go back up here. Okay, so that's done compiling. Let's move up. Okay, as you can see, this was our original dense layers. Let me get that out the way. This was our original dense layers with our 32 neurons, and then we increased it to 128. And you can see that increase here. You can see we now have 128 neurons for each of our dense layers. And each of the parameters that we can train on, we have 1152, 16,512 for the next two, and then 129 for our output layer. Then we move down to our new model.fit. So this is our new model.fit. Now you notice this value loss here. Remember how we had that huge number? You can see again we have 151,086. What we end up with is something much, much smaller. So we end up with 33,717. So that's because we did our we added more complexity to our model, and that helped us cut down on that huge gap between the value losses. So notice that our new losses are smaller magnitude compared to what we had previously. Also, how much we are able to reduce the underfit in our model. So with the complexity of our new model, we were able to reduce the underfitting dramatically. We went from 150,000 down to 30,000, and that was the exact goal that we were trying to reach. And you can see we did reach that with our complexity. And again, we're just going to keep on moving forward, and I'm going to keep you guys posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.